Okay, we just finished writing down this information, and this is 3.2.6, and I'm going to continue working on this first problem. So we just wrote down this information from our table, and now we want to check the shear strength. We're going to be using this formula. Again, this was from the PowerPoint we had, and this VA we're going to calculate from here. Again, this formula we got from 3.2.4 that we did before, and it's going to vary depending on what kind of loading you have on your beam. So this is not the one for every beam. You have to get the one for the correct loading. So here, Vn is equal to VA, which I got from number 2. So when we had right here from number 2, VA is right, or RA is right here, which is VA. I got that from number 2. And this number, 1.5, is the number we always use for the shear safety factor, multiplying at this answer. Then I also need to calculate Vn. Vn should be equal to 0.6 times Fy d times the thickness. This is from the PowerPoint. These two numbers, I'll show you right here. So this number right here, it was originally given in our problem under the criteria. Fy was given right there. And then these two are the numbers we just got from our table that we wrote down. That's the TW and the D. It's the area of the web. Plug these in, put it right here. And then I need to check if this is true. Well, this is Vn, and it is bigger than VA times my safety factor, 13,000. It's a lot bigger, so we're good. We can move on. If it wasn't bigger, we would need to go back and choose a bigger beam and then try this calculation again. Now we're going to calculate the deflection limits. So once again, this formula right here and this one right here, these were given in the PowerPoint we just saw, and these are the numbers for the plaster ceiling because in our criteria, we were told that we would have a plaster ceiling. So I plug in the length, convert it to inches, and then use the formulas from the plaster ceiling for the PowerPoint to get my two numbers. One for the total load, one for the live load. Now I need to calculate the actual deflections. This was the limit of how much it can be. Now we're going to see what we actually have. So this is again a formula that we had from 3.2.4, and again this one depends on the loading of your beam. This right here, omega, we got that in number 1 from our worksheet, and we needed to convert it. Our length, and we need to convert it. 384 is right there. E was given in our original problem, right here. And this was from our table. This is the I that we got when we did number 4 right here, IX. Crunch that up in the calculator and we see that we get 0.92. Well, what we need to check here is that the actual deflection is smaller than the allowable. Well, it's not. So this beam is not going to work. So now we need to try a bigger beam. So we go to the next bigger beam and we look up the information on it. Now I could just go in and plug this back in here and do this calculation again and then check if it's bigger than 0.9. This works nice if you've still got this in your calculator and you can just change that out. If not, there's a quick fix for it by doing it like this. I take the answer I got here, put it here. Then I want to cancel this one out. This is kind of an algebra thing. Cancel this one out here by multiplying it on top, which cancels it out on bottom, and then replacing it with this one. Basically, this little thing right here is just a ratio of the I from the old beam that we don't want to use and the I from the new beam you do want to use. And we get this new number. If this calculation doesn't make sense to you, just take the new IX and plug it in and recalculate this and check it. In this case, we do find that this is smaller than our allowable, so now we have a good beam. Now we're going to be using the 12 by 16 beam. I also want to check my live load. Same formula. It's basically the exact same calculation. I've just put my live load in here from part 1. And I've put in my new beam information that we got right there. Check, it is smaller than my allowable that I got right there. So it's good. So basically we're now down to select the final beam design, which was the 12 by 16. That's the one we found. By inspection, the plastic section modulus ZX and the web area are greater than in this size. And we knew that this size was okay. So therefore we're adequate and we don't have to recalculate them. Basically what we're saying is because the new one is bigger than this one, this is still going to be okay up here. We don't have to go back and calculate that. And that's all there is to this part. Now you need to do your exterior and your girders the same way. Be sure on those parts where I said it was dependent on the loading on the beam that you use the correct loading on each one.